Angles, remind me again what it means to be isosceles. Two sides are the same, and equilateral means all the sides are the same. Alright, so parts of our isosceles triangle. Your two sides that are congruent, we call those legs. You'll notice here, I know that they are congruent because they have the lines on them. Those are labeled legs. Your angle where your legs meet up at the top is called your vertex angle. Your side opposite the vertex angle is called your base. So our sides are called legs and base. And then your angles along the base have a fancy term. They're called base angles. Alright, we have two little theorems that come with isosceles triangles. The first one is about our sides. If we know that our sides are the same, so here, these are marked as the same, right? What would I call this side using two letters? Yeah, ZX. So if ZX is congruent to, what do I call my other leg? YX. So if those legs are congruent, then I can say your base angles are congruent. And the base angles are Z and Y. Okay, how you know which angles are your base ones? They go opposite. Or I like to think of it as like they don't touch that leg. So like if I have this leg, you notice how it touches angle Z and angle X? So the one opposite it is angle Y. Same thing here, X, Y, they touch X and Y. The one opposite it is Z. Okay, then the converse just says the opposite. If you know that you have two angles congruent, so if our base angle Z is congruent to our base angle Y, then you know the sides opposite it have to be congruent. So basically in isosceles triangles, if you have two sides the same, two angles are the same. If you have two angles the same, two sides are the same. Okay? And just don't pick the angle that's by itself, the vertex angle. Alright, do you all have that down? Okay. So, doing math, I know that these two sides are my legs and they're congruent. So if L is 68, how big is J? 68. Good. 68. How can I find angle K?
180 minus 68 minus 68.
Yeah, I know the triangles that up to 180. So 180 minus our two angle measures. 44. Alright. And the next one. I have two sides of the same. So D is my vertex angle because it's in between those two. So which angles have to be the same?
C and E.
C and E. Good. How can I figure out how big C and E are? Go.
180 minus 106.
Yeah, I'm going to take 180 minus the 106. That leaves me with 74. Does that, yeah, you have to divide by 2 because 74 is what's left for both of these, but we want them split equally because they're the same. So 74 divided by 2 gives me 37 for both of those. Okay. Angle X, easiest thing to find first. What do I know about 115 and angle X? They make a linear pair, so how am I going to find X?
180 minus
180. Yeah, 180 minus 115. So x is 65. Does that make y 65? No, this unmarked angle over here is 65 because it's opposite our legs. So now how am I going to find y?
180 minus 65 minus.
Yeah, 180 minus 65 minus 65. 50. Alright. Questions so far? Okay, we'll keep cruising. I have sides that are the same. So what do I know about these angles?
3.
They are equal, so how am I going to solve for x?
5x plus 9 equals 8x minus 3.
Yeah, set them equal. Subtract your 5x, add your 30, and x's
13.
Okay. Kind of opposite thinking, well, same sort of thinking, your converse theorem. I know that these two angles are the same because 74 is same as 74. So what do I know about these two sides? They're equal. So how am I going to find x?
Set them equal.
Set them equal. 9x minus 73 equals 3x plus 23. Subtract 3x, add 73. Yep. And then x is how much? Thank you, dear. Alright. Questions there? Okay, one more isosceles problem. Alright, it says an exterior angle of an isosceles triangle, so let's draw an isosceles triangle with some exterior stuff. So isosceles, two sides the same, and then I have this little exterior angle here that's 120 degrees. I want to know what kind of triangle it is. Well, I know it's isosceles, but let's use this angle measure they gave us. Can I find that angle?
Yes.
Yeah. How much is it?
60.
How'd you get it? Yeah, 180 minus 120, got a linear pair here. So this is 60. Since it's isosceles, what's this?
60.
What's top angle? 60. So what kind of triangle is it actually? Equilateral, equiangular, yeah. Can we just go equal, equal? Or does that confuse people? Equiangular. Angular, equilateral. Yeah, that's cool. People give me blank stares, not pretty goofed up there. Alright. Speaking of equilateral, go to the next page. Something that we kind of talked about yesterday. Ooh, don't do that. If all of my angles are the same, what do I know about all my sides? They're all the same. So if A is the same as B is the same as C, then I can say AB is the same as BC is the same as AC. So let's write that down. AB is the same as BC is the same as AC. Everything is the same. And then it works vice versa again. If all your sides are same, then all of your angles are the same. Angle A equals angle B equals angle C. And I'm going to throw back here that they all equal 60 degrees. Super important that is your angles, not your sides. Hello. Hi, bestie. How's it going?
Good. How are you?
Not too bad. Thanks. Appreciate it. So super important not to use angle measures for sides. Alright, so down here, I got A is 60, B is 60. How big is C? 60. If AB is 9, how big is BC? And AC?
9.
Easy peasy lemon squeezy? Yeah. How big are each of these angles over here? 60. And we know that because it says all of our sides are the same. Alright. Next one says triangle PQR is an equilateral triangle. Solve for X and Y. Which one to solve for first, X or Y? I don't care which one. Okay, X. What a good idea. What do I know about this angle right here? It equals 60. So let's try to do a 7x minus 3 and 60. Yeah. 7x minus 3 equals 60. Add your 3. And x is 9. Okay, here's the part that I know will throw people off. Just don't overthink it. Do you notice that I have 3 y things? Okay, those things are sides. What do I know about all of those sides? They're all the same. They're all equal. Can I set them all equal to each other? Like 14y minus 59 equals 9y plus 1 equals 11y minus 23? No, just 2. Good. So you pick any 2. It does not matter. I like lower numbers, so I'm going to ignore the 59 because big numbers scare me. So literally, you just choose 2. Okay? And what am I going to do with those 2 things? Good. 11y minus 23 equals 9y plus 1. Subtract your 9y. We get 2y. Add your 23. We get 24. Y is beautiful. Okay, so when you have 3 things, only use 2. I shouldn't say that, unless it's like a line and you have 3 angles that are up to 180. But if you have 3 sides or 3 angles, you just need 2. Can I scroll down? Okay, good. Alright. Here, you'll notice I have a mixture. What kind of triangle is ABC? Equilateral, yeah. What kind of triangle is CDE? Isosceles. Okay, so if I want to find ACB, so ACB, that's this angle here. How big is it? 60. And then I have DCE, so DCE, that's this angle here. Is that one 60 as well? No. How do I find it? Good. I know that triangle CDE adds up to 180, so subtract out that 50. That leaves me with 130 for both of these angles. So split it in 2. We get 65 for that angle. Did I not label that one? My bad. Alright, and then how can I find BCD, this angle here?
180 minus 65 minus 60.
Beautiful. We got a line here. Lines are 180, so all 3 of these. So 180 minus 65 minus 60, 85. Then there's this fancy question over here that says, is C a midpoint of AE? So if I look at AE, that goes from here to here. Basically what it's asking is AC the same as CE?
No.
No, it is not. Good. On this next one, I forgot the word angles in here. So triangle has angle measures. 5x, 2x plus 3, and 3x minus 23. What type of triangle is it? How many total degrees in a triangle? So what should I do with all three of those? Add them up to equal to 180. Can we skip a step? Okay. X's, how much total x's? 10. Plus 3 minus 23 gives me a total of negative 20. And you said triangles add up to 180, so they must equal 180. To solve, add your 20 and x's. What? 60? Did I do that wrong?
No, I got
Okay. Kind of scared me. Alright. So the fact that x is 20, does that answer the question of what type of triangle it is? No. I gotta plug x back in here to figure out what kind of angles I have. So 5 times 20 gives me how much? 100. And then we got 2 times 20 plus 3 gives me 43. Then we got 3 times 20 minus 23 gives me what? 37. Are any of these angles the same? No. So can it be isosceles? Can it be equilateral? So what type of triangle is it? Scalene. Nice. Alright, last one. Legs of an isosceles. Look, a penny, its heads up. That means you'll have to luck all day. Alright, legs of an isosceles, 3x minus 2 and 2x plus 10. What do I know about the legs of an isosceles triangle? They're equal to each other, so what should I do with these two things? Woo! 3x minus 2 equals 2x plus 10. X is what?
What?
What'd you do?
Am I bad?
What?
Okay.
Don't laugh at me.
Hey, I make lots of math errors. Alright. So it says the base has length 4x minus 5. What's the length of the base? So do I need to set, are these equal to the base too? No. So we use these to get x. Now what should I do with this x?
Like I said.
There we go. 4 times 12 minus 5 what? Did you give me the answer? No.
What?
Okay. 43. I didn't know if you gave me the answer or not. Alright, so there's a couple things that try to throw you off. First off, when you're given all of the sides equilateral, only use 2 of them. In problems like these, make sure you set the legs equal and not the base equal. Questions? No?